Okay, question number 7. We have an electric circuit that contains power source with a time-dependent voltage, resistor, and inductor. The current I flows through the circuit is given by this differential equation, and we need to show that the solution is as follows when the condition is given. So let me rewrite the differential equation. We have L di dt plus Ri equal to V. So this is not a typical differential equation that you see, because usually we have yx dy dx, but now we have di dt. So it's important to make this note. Okay, so if we have dy dx, we know that these are the variables. Okay, say I have dy dx equals to negative 2x. Okay, so we already know y and x are the variables. Other than y and x, which is negative 2, is considered as constant. So in this case, I have I and t. So I can say that I and t are the variables, while the other term L, R, and V are considered as the constant. So write down beside here as your reference when you try to solve this question. Okay, so constant, remember, even though they are in the form of letters, huruf, okay, it can also be a constant like this, like numbers. Okay, so we already take note about the variables and constant. To solve this, first of all, I always emphasize you to try to use the separable variable method. Let us try first whether it is possible or not to use separable variable method. So what I will do is to separate the derivative and function. So here I just bring to the other side and become minus. Okay, and then if I want to bring dl to the other side, I will get di dt equal to v minus ri divided by l. So again, if we take note about this, v, r, and l are all constant, right? They are just like numbers. Say I have 2 minus 3i over l, or over 4, let's say. So they are just constant. So we can do separable variable in this case, right? Okay, let me show you how separable variable is possible. Okay, since the yellow one over here are constant, I can bring all of them to the left hand side like this. So I will have L over V minus Ri di, and dt will be on the other side. Okay, so this is possible because all of these are constant. Okay, so next we will integrate both sides. Okay, so this is a reciprocal function, so I can have ln as my answer. Okay, so this will become L ln absolute V minus Ri, and if we try to differentiate this, we will get negative R. Okay, because again, these two are constant. Okay, next, the right hand side will be T plus C. Okay, so let me bring L over negative R to the other side. By the way, you can also write this like this. Okay, over negative R. You can also write it like this, not necessarily a big fraction below the ln. Okay, these are equivalent. So if I want to bring this to the other side, it will become ln V minus Ri equal to negative R over L T plus C. Okay, I can expand this to be like this. Okay, so this is still ln V minus Ri. So, how to solve this and get I as our subject? You can have exponent on both sides. Okay, and hence the left hand side will be V minus Ri, while the right hand side you can write it like this: E negative R over L T minus R over L C. Using the rule of index, you can separate the E like this, and we can write beside here, if we let E negative R over L C to be a constant A, then the right hand side will be E negative R over L T multiplied with A. Over here, we can denote as A because all R, L, and C are constant. While here, you cannot denote as A because we have T, the variable. That's why it's important to state in the beginning what is the variable, what are the variables and constant. Okay, so let us continue with this. So I have to make I as my subject. Okay, so let me rewrite over here. So if I want to make I as my subject, I need to find the value of constant A first. Okay, so how to find the constant A? We will use this information over here. It's given I equals to 0 when T equals to 0. Okay, before we can prove to this statement. Because if you look over here, there's no A, right? We only have constant L, V, and R. Okay, so we use this information, I equals to 0 when T equals to 0, and substitute over here. So I will have V minus R times 0 equals to E negative R over L times 0 multiplied with A. Okay, so this will be V equals to A. Okay, because over here E power 0 equals to 1 and this is 0. So obviously V is equal to A. Hence, we can substitute V equals to A inside here. Okay, so what we will have will be V minus Ri equals to VE negative R over L T. I hope you understand. I just write V in front. Okay, so let me rearrange. Okay, so I have V minus VE negative R over LT equal to Ri. Okay, hence I is equal to, you can factorize the V and the R over here will be divided like this. Okay, so we already show a statement that is required in this question. Next, we go to question B, where we need to determine the value of T. Okay, we will start by writing the result that we obtained in part A that we already show, which is I equal to V over R 1 minus E negative R over L T. So this is the result that we obtained in part A. And the second part of this question asks you to find the value of time if I is given as V over 4R. So just substitute the I. Okay, and we have the remaining expression just exactly as above. Okay, so this topic really tests you how you manage to solve this kind of problem. Okay, algebra lah, basically kemahiran algebra awak. Okay, so if you cekap, you akan cepat dapat solution. If not, you akan kial-kial sedikit. That's why kena banyak latihan. Okay, so ini nampak we have V over R on both sides, so we can cancel out this 2 because it's multiplication. And then I will write down, I have 1 over 4. Okay, so if I bring the E to the other side, I will have this. And 1 minus 1 over 4 is 3 over 4. I can have ln on both sides. So the left hand side will just be this. Okay, and hence our T is equal to this. I just bring this to the other side and it will become negative L over R ln 3 over 4. Okay, so this is my answer for part